So in this video, we will see some basic concept related to physical design. First, we will see the interconnects. So for making interconnects, we use several layers of interconnects and we separate two different interconnects layer by an interlayer dielectric. And two interconnect layers are separated through a wire and they are connected through a wire. So the thickness of the interconnects in different layers can be different. As we can see in this diagram, the thickness of interconnect layers increases from the bottom of an IC toward the top. So we can see the thicker layer of interconnect at the top and smaller layer of interconnect at the bottom. So when we increase the thickness of an interconnect layer, its sheet resistance decreases. So what we do, we employ thick top metal layers with low sheet resistances for global interconnect and in power delivery network. So the top interconnect has low resistance interconnect and it will result in smaller voltage drop across it. So thick top metal layers in power delivery network can be used to maintain a uniform supply voltage across the circuit. So now coming to the resistance part, what we have to take into account when considering the resistance. So at high frequency, current tend to flow on the conductor surface and the core of the conductor remains effectively unused. As a result, at high frequency, the resistance of an interconnect tend to increase. This phenomena is known as skin effect. So it is becoming this effect is becoming important for wider and thicker wires at the top metal layers. So the skin effect is important in clock lines that are generally routed at the top metal layers and work at a high frequency. So we have seen the use of top interconnect. One is for power delivery network and another is global interconnect and third is for clock lines. So let's talk about another important factor that we have to take into account while selecting the top interconnect, and that is the inductance part. So as we can see, as we are using the top interconnect for high frequencies for clocking. So at high frequency, the impedance j omega L will tend to increase. So we can no longer ignore the inductance. So we have to consider inductance also while considering the top interconnect.